When I look from my home directly to the south, I see some mountains, and I know this man is living behind these mountains. Welcome Jan Schorsch from Slovenia on stage. And I think we never met in Europe, by the way, just saying, okay? So, thank you. Welcome Jan for his presentation.
Hello everybody, I'm Jan Schorsch. I'm coming from Slovenia, working for 6Connect, and thank you for having me here. I think it's my third time in Oman, so I love this place. Okay, in interest of time, let's talk about Anycast. Who in the room is familiar with the Anycast concepts? Excellent. So I don't have to go through the basics. We can go straight to the interesting stuff. Okay. So, our starting point. When I joined the 6Connect, that's a global company, and we thought that our DNS platform should be global too. So when I started there, the company had a set of DNS servers around the world that were named NS1, NS2, NS3, NS4, NS5, and so on and so on and so on. And I thought that there are better ways how to provide the DNS service for our own company. So my job at the company is I'm the head of the lab. So I'm running the lab for our developers. And Sander, Stefan also joined the company at that time. And I thought, well, if we are running a lab, we need to do some experiments. So why not building the Anycast network, the global Anycast network? Why? Well, because we can, right? To see how that thing works. I know many Anycast networks are being built around the world, but you know, I usually learn experience by doing it, not by reading about it. So Sander and I just sat down and did a plan. I usually don't plan much, but this was basically the plan. Let's build a prototype, set up measurements, fine-tune the prototype, more measurements, done, right? That sounds quite easy and straightforward. Oh boy. And my presentation is basically sort of like a documentation of our process, how we went through the thought process, how we did some decisions, where we failed, how we fixed it, and moved forward. So, for the software choices, we said, okay, we have bind, we have not DNS, we have NSD, we have power DNS. So which one can we use? Well, why don't use all of them? Because we can attach them to the local loopback, listen on the different ports, and put the DNS dist in front of it, listening to the port 53, and distribute the queries to the backends on different ports. Why? Because if you upgrade any of these softwares, you may run into problems with new bugs, things may fail. So we said, okay, all four of them, they cannot fail at the same time. So at least one will provide some answers, and the DNS dist will understand which backend is providing the answers. We used the BERT2 for the BGP routing, for the Anycast prefixes announcements, and Ansible for automation. That's Sander's part. He is master of automation. And of course, it would not be me if there would be no bash sed awk for scripting things. So, as I said, we use DNS dist for the front end for scripting. And we used ZoneSync. We built the Python script to update the zone files around the planet at the nodes. We actually scripted the daemon that we called Damocles, because that script is holding the sword. And what it's doing, it's querying DNS dist for the DNS queries, and if there is no answer back, that means that that node is dead and kills bird to stop announcing the Anycast prefixes. So it removes itself automatically from the Anycast pool. And then we started with the first nodes. So when we had a prototype in the lab, working prototype, we started building the first nodes. So we built in Fremont, Ljubljana, and Apeldoorn, where we already had the hardware and the racks. It's not a really good spread, but it's a start. So then we started thinking, which IP resources to use, how many of them, how big are the prefixes, which AS numbers. And then we decided to start announcing 3 times /24 of IPv4 and 3 times /48 for IPv6. Why /24 and why 48? Because this is the shortest possible net mask that you can actually announce in the global routing table and would pass all the filters around the world and actually get somewhere. And we have 3 nodes in each location. Each one is announcing primary IPv4 plus IPv6 plus secondary IPv4 plus IPv6, and I will tell you about this later. So usually the primary prefix is with high priority, secondary prefix is with low priority, and where we use iBGP, we use local pref for the preferencing, and eBGP is of course used by we are prepending stuff to differentiate between the primary and the secondary prefix. So this is the architecture. Is there a laser? Ah, there is a laser. Okay, so you see here, we are using the first Anycast node is announcing these 2 prefixes as a primary, and secondary are this. But this secondary here are primary here. And this secondary here are primary here. And this secondary here are primary here. So it's the full circle. It's like octavarium. So in this case, we can switch off completely any node out of 3 and nobody would even notice. Because the node that is announcing the secondary prefix for the node that we just switched off or is dead will just take all the traffic, and all 3 nodes are responding in the same manner, same answers. So actually nobody figures out that one is down. So when we set this up, we started thinking about measurements. So does it work? How? How does the world see us? How are we visible over from the global internet? And the route views helps a bit. RIPE Atlas provides some information, but not very detailed. And then later on, we figured out that we need an order of magnitude more vantage points around the world to measure the Anycast network, because it's Anycast. You know, you go to the nearest point, hopefully, and from one vantage point you can just see one node. You can't see all the nodes around the world. This is a little bit tricky. Properly measuring Anycast is the trickiest part of this business. In the meantime, we thought of deploying more nodes. We started deploying them on VMs around the planet using the Vulture provider. And meantime, we moved our 6labs.com domain to Anycast because we need to eat our own dog food, right? So what could possibly go wrong? That domain didn't fall off the internet. It's still working from day 1, so all good. We did all the tests and things went quite well. So about our own control and monitoring, we use our own software. The 6Connect is making the IPAM and network automation software. So, of course, we had to use our own software to control the whole thing and push the zones and edit the zones for the Anycast network. And we use LibreNMS to keep track of DNS disk queries, performance, and uptime, but this is only for in a unicast way, not in the Anycast way. So we are just monitoring the nodes directly. Then we had more Anycast ideas. The initial prototypes was authoritative DNS. We can also do recursive, of course. So what about HTTP, HTTPS? Why not? If you use Galera and replicate your database across the globe to many locations, you could actually potentially use the Anycast. And we're using it now. If you go to www.6connect.com, you will end up on Anycast web server. Well, you will end up in the closest node possible. Then we were thinking about the high available mail service. Why not? Having the SMTP receivers all around the planet Anycasted, what can possibly go wrong? And so on and so on. Many, many ideas in the lab. Then we did some design decisions. Not all services need to be in all Anycast locations. Then we started to think how many services we can host in 1/24. Well, we can host many of them in /48. And then we started building the HA proxy as the front end for the Anycast load balancer, because then you can proxy when people hit the Anycast node with the HTTP HTTPS traffic. You need to proxy it back to the backend servers. So this was used for this, and then we immediately hit the problem, because we use we are using the Let's Encrypt certificates, and if you do the ACME verification over HTTP, then the Let's Encrypt verifies over HTTP for the ACME challenge, and then adds up at any Anycast node that is nearest to the point where they are validating from. And then we had to build some sort of proxying back to one node and doing all the renewal stuff on one central node. But then we figured out we could also do the DNS authorization. So now we switched to DNS authorization and we are done. But this is still there for the historical reasons. But then the dilemma stays. Are we globally visible? Are we creating any black holes around the planet? Which networks are sending traffic to which nodes? Is one part of the planet sending traffic to completely another part of the planet? So are we making our users take the large detours? And you know, all these questions that you can read here, this was all going through our minds. When at some point in time, Sander and I met in Apeldoorn, where he lives, to develop this further, and Remco van Mook invited us for dinner. And we had a really, really nice dinner at Remco's house. Remco, you have a best whiskey. And then Remco said, hey, guys, I'm starting something new. I'm thinking about something new. And he showed us his new measurement and monitoring system that he was working on. And I was stunned. I was standing there behind Remco and said, Remco, this is exactly what we need to measure the Anycast. Exactly. It was a complete unicorn of a measurement. And the pictures that you will see here, they are snapshots from that tool. So if you want to talk about this tool, talk to Remco. He's sitting there in the corner. Yeah, but this is really, really good tool. I was looking around for a tool like this for a long time, and it was sent from heaven. So here at some point in time, we had a couple of nodes around the world, and let's see. So follow the, you see this arrow? This is the POP in Fremont, and you can see the latency, the RTT from around the world. Red is over 200 milliseconds. Green is less than 200 milliseconds. So why is people from Russia going to a node in Fremont? Global BGP. You see, this is Miami, and still people from Russia is going to Miami, and parts of Africa and India that is having over 200 milliseconds of round trip time. You see, okay, this is well behaved. This is in Brazil. This is quite well contained. Then we have Appledore, and this is well peered. It's on M6, and you can see people from all around the world, even from Indonesia, are going to Netherlands for some reason, despite the fact that we have a node in Singapore. The magic of global BGP. This is Ljubljana. This is my hometown. You see, people from Australia are coming to Ljubljana for some reason. This one is in Singapore. Yeah, well, okay, quite nice. Not too much of red. Then we have Japan. Of course, also people from Russia is coming to Japan, and we have Australia that is fairly well behaved. So you see, in that tool, you can see these things. You can see the preferred POP of every country around the planet, and this measurement was not done from tens or hundreds of vantage points. It was done from millions and tens of millions of vantage points from around the planet. How? I have no idea. Ask Remco. It's magic mixed with witchcraft and some other stuff, probably. Okay. Then we switched on the node in Joburg, South Africa. And you see the mess that this created. I will explain this particular case later. So what's the dominant POP? So there are the pictures, and you see that the dominant POPs are all around the place. But you see how it changes over time. See, these are daily snapshots, you see? And the global routing changes a lot. And having a tool like this was fantastic. So then we started adding new POPs. So before Brazil, Sydney, and JMB, Joburg, this was the picture of the world. This was how our Anycast network was reachable, the RTT. And you see that we are neglecting the southern hemisphere, basically. Then we added Brazil, and you see the things went green in South America. Then we added the POP in Australia, and the other part of the planet went green. And then we added the Joburg node, and another part of the planet went green. And this is really important. If you want to understand how your Anycast network works and how you're reachable, you need a good measurement. Otherwise, you just throw hundreds of points of presence around the world and hope for the best, because you have no idea what's going on. See. Okay, Joburg, too well-connected peer. We announced this to Work Online. That is the ISP in South Africa. That is one of the best peered ISPs in that part of the planet. But unluckily, they are a paying customer of one biggest transit provider, global transit provider. Sorry. And this transit provider that I shall not name, despite the fact that this transit provider received our announcements in Japan, in South America, in North America, in everywhere around the world, from the ISPs, from the IXs, from everywhere, all of a sudden they decided, hey, there are these prefixes coming from our paying customer. Bang. Redirect all the traffic from all the world to Joburg. Thank you very, very, very much. And then the trouble started, because all these people started to have suboptimal service. Thanks to this tool, we were able to measure what went wrong. And then now by default, we put in our BGP configurations, the BGP community do not export to this IS number by default on all of the POPs. And the whole thing went green all of a sudden. I need to figure out how to set up a POP at their facility somewhere well connected and actually export the Anycast prefixes to them, so that also their customer get the better service. But you know, usually I was taught in the last 30 years of doing routing that we need to do the hot potato routing. That was what I was told. These people is doing frozen potato routing. They just put it in the fridge and just send it all around the world. It's not how internet should work, right? We are monitoring stuff with the Grafana. This is a very nice tool to see what's going on your system. And the present state, we are running the Anycast DNS services for our own zones. We are also hosting the Ukraine.ua TLD because when the war started in Ukraine, we offered them for free to reinforce their TLD structure, and so they took it. So now currently we are hosting the whole CCTLD there. Also we have other customer zones. And we are now building the distributed and Anycasted mail system for our use, and also the Anycast IPAM service. And we also think about simplifying the Anycast node. Maybe it's too complex because not many things went wrong. So we are probably cutting down the number of different DNS daemons and make it a little bit simpler. Mark, are you happy? Very happy. And that's it. Are there any questions? Do we have time for questions? Yeah.
Hello, I'm Ehsan from Iran. I have a question for you. What tools did you use to monitor the Anycast? You know, the RTT, how did you measure it? Did you use any specific tools to measure the RTT to any Anycast server you have?
Yes, we use the tool that Remco built. He's there. Maybe Remco can come to the mic and explain. In few words, and then they are suggesting lightning talk for you.
Well, I'm not going to do a lightning talk from the microphone here. That's probably not appropriate. The long and short of it is that the tool uses a whole range of access to client devices, very similar to Jeff Houston's IPv6 measuring project, where he puts a 1 pixel advertisement into a web page that he then has clients basically look at. This is very, very close to that sort of idea. And that's as detailed as I can get without actually turning this into a complete lightning talk, which I won't.
Thank you, Remco.
Thank you, Jan. And next time we meet in Ljubljana, okay? One day, or in Klagenfurt, let's see, okay? It's not too far, it's not too far. Yes, definitely, definitely.